Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and we're talking about cubic graphs and being able to just recognize them, not necessarily draw them from a table of values. Now, in the last video, what we did was we drew the following cubic graphs from a table of values. So y equals x cubed, y is negative x cubed, y is x cubed subtract 3x squared add 1. And they are as follows. So we had a table of values, we worked out the value, the y value matching various x values, and we tried to plot them. And y is negative x cubed looked like that, y is positive x cubed looked like that. We said they were a reflection of each other in the y-axis. And the other one, y is x cubed subtract 3x squared add 1, looks something like this. Now, we can always revert back to a table of values, but for some cubic graphs we do need to just be able to spot them and recognize them, especially against other types of graph like linear graphs, quadratic graphs, other cubics, and we might be asked to say which one of these is a cubic graph, and that's all we're practicing in this video. A nice easy particular skill. So just to start with, let's summarize what we've learned and some of the key features. This graph here, if you ever see anything that looks like that, it's a graph of the form y is equal to x cubed. And you could say some lots of x cubed, ax cubed, like y equals 2x cubed, y equals 5x cubed, that type of thing. But the important point for these graphs is that a is positive number. Alright? A must be a positive number. And the key features then about graphs like this is they start down here in the bottom here where x is negative, y is very negative. They come up here and they go through 0, 0, that's very important, and then they shoot off to infinity. As x goes very big, y goes hugely big. Okay? Now, this graph here is the graph y is equal to ax cubed as well, but this time for a that is negative a's, and they are always a reflection of this graph in the y-axis. Okay, and they start when x is very negative, y is very, very positive, very big number. They come down, they go through 0, 0 as well, and then as x gets very positive, they shoot off towards negative infinity. Now, graphs like this, cubics then start looking like various combinations of these two graphs here. Not always, but they look a lot like these ones. So a general cubic is of the form y is ax cubed, some x cubes, plus they'll have some x squareds, plus some x's, plus a number. They'll look that type of thing. And they're kind of like this graph. Let me just explain how. Other than they tend to be, for this bit here, pulled upwards. Do you see? Pulled upwards to like there, stretched up in that direction, and at the same time this part of the graph tends to be pulled downwards to there. So they've kind of been pulled apart into things like this. Now the key is here, again, this one, when x is negative, y is very negative, okay, and they come up, they may have a what's called a turning point, and then they start coming down, they have another turning point, and then as x gets very positive, y goes very positive as well. The key with ones like this, a is positive. They're very like this graph, apart from, as I say, they've been stretched in those directions. And similarly here, I guess you can understand the message. These ones are exactly alike, other than a is negative in this case. And you can see here that for this part of the graph, can you see that they've been stretched downwards to here? And can you see for this part of the graph, it's been stretched upwards to like here. Alright, so they're like kind of how you see cubics. There are other variations of that, but sometimes you'll just be asked to look at a graph and say, is it a cubic, is it a linear? And these are the type of things that need to be in your head. Right, let's do those very example questions. So which of the following could be the graph of y is x cubed? Pause the video, have a think. Well, it's not that. That looks like a quadratic. It's not that. That's a linear. Could be that, but we should be looking at that and thinking negative x cubed. Could be that, although we know y equals x cubed goes through 0, 0. This one doesn't. This one looks like it's going to do the trick for me. So the answer for this is E. This is the type of thing you need to recognize quickly. Let's have a go at another one. Which of the following could be this graph here? Y is 3x cubed subtract 2x squared add 1. Pause the video, have a think. Again, couldn't be this, quadratic. Couldn't be this, straight line, linear. Couldn't be this, this is a negative x cubed graph. Could it be that? Well, it kind of looks like the x cubed graph. It's been stretched in the ways I talked about. This graph here has a positive amount of x cubes, so I'm thinking it definitely is that one. The only other option is, could it be this one? Well, we know this one is like the y is negative x cubed having been stretched. So we have positive amount of x cubes. It must be D. So the answer for this one is D. Another one, which one's the graph of y is negative x cubed? Pause the video, have a think. Okay, hopefully you just spotted very easily that it must be C. C is the only option there. What about that? Which one could be the graph of that? Well, it's going to be a cubic because we've got x cubed and we need negative lots of x cubed. This one and this one are the only two negative x cubics. This one we've already said is just the graph y is negative x cubed. This one is therefore our only option. The answer is F. And lastly, which one could this one be? Just linking back to some prior knowledge there, I wanted you to spot that there is a quadratic. Quadratics are a parabola shape, a U shape or an N shape. The only one that fits the bill there is A. Now just before we go on, the only one we've never labelled is this one. What type of graph is that? It's a linear graph. It would look something like y equals mx plus c. It would have a x to the power of 1, okay? And that's it for this particular video. Thanks loads for watching.